Hello MSc, today I discuss the topic of metal pi acid complex. So firstly we study the metal carbonyl compound. So metal carbonyl compound are those compound when the metal is bounded in carbonyl group. Where the metal is a Lewis acid and carbonyl is a Lewis base. So some important points of this compound. Firstly, carbonyl is not considered very strong base. So it forms a strong bond with metal. Bond with metal. And second point, the metals are low oxidation state. Metal की क्या होती है? Low oxidation states. This is mostly a zero. But sometimes low oxidation state is a positive oxidation state and a negative oxidation state. And third point is it obey 18 electron rule. Where is a EAN rule. And fourth is a metal carbonyls. The metal carbon bond possess a sigma and pi character. Sigma and pi character. The bond between the carbonyl molecules and the metal is a strongly synergistic effect produce a metal ligands. It produces a synergistic effect. So first is the sigma bond between the carbonyls and the metals. It forms a sigma bonding between the ligand and metals. And second is the pi back bonding between the metal and ligands. So three type bond is observed in the metal carbonyls. So first is a carbon and oxygen bond between the carbonyl groups. It's the metal carbonyls is the strength of metal carbonyl is always depend on type of metal used. Strength is always depend upon the what is the metal used in which carbonyls group. And second is a metal and carbon bond between the carbonyl groups, metal carbonyl groups. So in these points, the transition metal have of 9 orbital. Transition metal have a 9 orbital. This is the 5 Nd orbitals and 1 N plus 1 S orbitals and 3 N plus 1 P orbitals. These orbitals show a strong tendency to utilize all of them in forming a bond. The strong tendency to utilize the all of bond formed. And second is a metal, carbonyl and S, where X is show that the orbital of S, P and D of make a metal carbonyl group are used to formation of metal and carbonyl sigma bond will sidewise overlapping, and the filled metal d orbital and empty pi molecular orbital of the ligand form a metal and carbonyl in a pi bond. And other is show that a synergistic effect. And when the metal and their carbonyls donated the electron of the metals, this is called a sigma electron donation by a carbonyls. And other hand, the metal and carbonyls is a pi acceptor. These are the pi acceptor to form a overall insertion of the carbon and the metals. And third type is a metal-metal bond. So these are the polynuclear metal carbonyl. On either alone in manganese 2 and cobalt 10 combination is a bridged carbonyl group. इसमें क्या होता है? Bridged carbonyl groups. So example iron and carbonyls. So this is a brazed carbonyl group. And second, I will discuss the molecular orbital diagram of the carbonyl. This is the molecular orbital diagram of the carbonyl. So this is the carbon electron and this is the oxygen electrons, and these are the bounded to each other, and these form antibonding and bonding molecular orbitals. The main feature of the molecular orbital diagram of the carbonyl group is a HOMO of the carbonyls to show a sigma bond with easy orbital of metal by a linear combination. So we will discuss the easy and the 2z orbitals in a previous videos. On the other hand, the metal T2z orbitals is a pi bond with a LUMO of carbonyls. Therefore, carbons become more positive and oxygen become a more negative of the carbon with a metal. The metal induced polymerizations activity of carbonyl ligand, hence carbonyl become more sensitive onward the nucleophilic attack, while oxygen will come more sensitive toward electronic attack. Where this is the carbon and oxygen, this is negative and this positive, where nucleophilic is attack, and in this side the electrophilic is attack. And we will discuss the structures is a mononuclear, binuclear and polynuclear. Mononuclear will have a metal and carbonyls bond, and binuclear is bond between the metals, and polynuclear is a more than two metal bonds. Thank you, and please subscribe my channel. Dhanyavad.